Okay, micrometers, what are they and how are they different from calipers? You can think of a micrometer as a more accurate caliper, but one with a more compressed range. Our calipers in the Makerspace reach 6 whole inches, and our micrometers only reach 1 inch. But across that range of 1 inch, we get 10 times the precision. We get a whole extra digit worth of meaningful data. Where a caliper is accurate to 1/1000th of an inch, a micrometer is accurate to 1/10 of a thousandth of an inch. And like a caliper has one more digit that flickers between 0 and 5 and is somewhat meaningless, so too does a micrometer. You can mostly ignore this 5 or the absence of the 5. The micrometer handle has a large barrel and a small barrel. You can use the large one to start to close the jaws, but please don't finish the job with the large one. Only use the small barrel, which has a built-in clutch, to finish closing the jaws. And when you think about that clutch mechanism, imagine the faces of the jaws making contact with each other. Then imagine yourself continuing to add force into the system by turning the small barrel until you hear a decisive click. That click is the clutch mechanism telling you that you've arrived at just the right amount of torque. Good, now that you know how to close a micrometer, let's clean it, because it is such a sensitive piece of measuring equipment that it loves to measure the dust, skin cells, or grime that have landed on the faces of the jaws, along with whatever you're trying to measure. To clean them, just open the jaws a bit and insert a clean piece of printer paper and close the jaws onto the printer paper until you hear the same click. Then, with the jaws closed, drag the paper out from between the jaws, imagining that you are dragging all the grime with it. And here you can see it making an oily stain on the paper. So oily that I'm putting it in again to confirm that they really are clean. Once they're clean, close the jaws on nothing at all to then confirm how inaccurate the micrometer currently is. And notice how if this were a caliper, it would suggest things are perfect. But with a micrometer, we can see that we are 6/10 of a thousandth of an inch off from a proper 0 point. Hit the reset button in this closed state to establish 0, and then start to feel pretty good about measuring things. And the first thing you want to practice measuring with a micrometer is nothing at all. Open and close the jaws at least 5 times to practice the amount of force necessary, even with the clutch mechanism, to land at all zeros all of the time. Once you can do that repeatedly, then move on. Now let's confirm that this measuring instrument really is more accurate than a caliper. Take the same 4-inch gauge block that we used in the caliper video and walk along the edge. Notice how with a micrometer, I can notice quite a difference. At one end, I measure 3511, and then across the middle, I come down to 3508, and as I approach the other edge, I come back up to 3511. That's a 3/10 of a thousandth of an inch difference across the 4 inches of the gauge block. It's interesting because it's measurable because of this tool. If I only had a caliper, I would not be able to see that difference. With a caliper, all along the gauge block, I get 3515. I can't see that there's a more complicated story here. And with my gauge block, I can start to question its accuracy, especially a gigantic 4-inch long gauge block like this. Nothing is perfectly accurate, and the micrometer is able to see that and thus quantify the inaccuracies. So what do you measure with a micrometer? Well, we measure our tools. We can ask questions like, is this really an 1/8-inch drill? And when we put it in the micrometer, we can see that it's actually smaller. A perfect 1/8 of an inch would be 0.1250, but this drill and all the other 1/8-inch drills that I've got in the drawer measure at 1242. And seeing that all drills measure a little under their stated value can let you ask interesting questions like, do drill manufacturers not know how to make drills of the correct size? Or is there some other reason here? You can measure things like this precision ground steel pin. Notice how as I sample the diameter of the pin at various points about its axis, I always get a measurement within 1/10 of a thousandth of an inch, 2496 or 97. That tells me this pin is very, very round. Compare that to this 1-inch piece of mild steel, and I get a significantly less round notion of my cylinder. I'm several thousandths of an inch out of round, according to the micrometer. It's also very good at discovering tapers along your geometries. Here's an object with a significant taper. Notice how as I sample the object down the axis of it, my number descends, revealing the taper. And just like our calipers, we've got a coolant-proof equivalent of the micrometer. It costs 3 times as much, so use it with care, and probably only use it when you're needing to take a measurement inside of the mill without unclamping what you're interested in. That's micrometers. You might have noticed that they're only good at measuring outside dimensions. Yes, they make inside dimension micrometers, but for our inside dimensions, we're going to use a pin set, which is the topic of the next clip.